What's up, dude?
Hey, Jake.
How are you, Jake?
I'm good.
Nice. How are you, YGG?
Yeah, I'm doing real well. Doing good. Had a good week.
Yeah, I can tell. I see you super active everywhere.
Yeah, I'm all rested
I really,
from the holidays.
yeah, yeah.
Hey,
I'm
folks.
just gonna. Oh, hey Blair, nice to see you.
Thanks, Sean. You too.
Yeah, how's your holidays? Happy New Year.
Yeah, it was good. I was in Georgia, and we were just kind of hunkered down with my girlfriend's parents, and it was really chill.
Georgia, like the city? Wait, is that a state or country?
Atlanta's the city, but yeah, Georgia is the state.
Were you in Atlanta?
Close to. It's a suburb outside of Atlanta. A lot of people don't actually live in Atlanta, or if it's people, a lot of people live in Atlanta, but it's a massive like suburb kind of vibe.
Hey, Griff.
Hey guys.
Okay, I'll share my screen.
Sam, we need to talk at some point. I don't know when. It needs to happen. I'll put a small agenda on our Telegram message.
Okay, cool. So I am streaming. We're live and recording. So we'll give it another couple minutes in case there's any late stragglers. Anyone else want to give? Hey Sam? How's your New Year's?
Very well.
Wait, what'd you say?
I could rest a little bit. Very well. I could rest a little bit.
Oh yeah, same here. It was nice to just get away from the computer for a while. Hi Santiago.
Hi everyone.
Nice to have you here. Okay, so if you guys want to get started checking out what we have planned for today, I just dropped the link to the Notion workspace. I also pinned it in the channel, so it should be easily accessible from now on. I'm also streaming on Twitch here, and I've been streaming quite a bit lately. Whenever I'm hacking on open source stuff, I tend to throw on the stream. It's pretty easy. So keep an eye on that. Follow me on Twitch. Yeah. So I guess everyone found the Notion page, so you can go ahead and open up Lab 5 here. And one thing to note, oh yeah, let's start this. So let's keep this attendance going. We can use this as I plan on sort of using this later as a data sheet to do some analysis on, but so I'm just gonna insert a column. Okay. And everyone can punch in their favorite emoji. Not sure why this one got copied over, but that's fine. Okay, so let's see. Penguin for Linux. Alright, let's see who can find the spreadsheet first. The lab is meant to be interactive, so I recommend everyone to follow along if you can. It's okay if you just watch too, that's fine. Usually Tonga's the first one. Okay. So PKK, oh, it's in general. We are in general. Voice chat. I'm not sure how to send a link to that, but So can you guys follow the Notion page and the attendance sheet? Just chime in if you guys ever face any issues or any questions, anything like that. I just want to see that people are tracking. There's Tonga. Okay, good. Okay, so things are working. Okay, so I'll let the stragglers fill in their emojis here. Just want to make sure people can track these resources. And when you get a chance, when you're finished with that, oh, nice. Someone's coming in with the robot. Santiago. Good. Okay, so here's the Lab 5, Visualizing Economic Templates with Holoviews. So I just put a rough schedule here. I'm gonna open up some resources. I'm gonna show you guys the workflow of actually discovering these libraries and how to navigate the documentation and how to run the examples. So that's gonna be really helpful if you want to kind of carry this work forward that we're gonna get started on today. It's going to be really important. I'm actually planning this to be a two-part series. We started it a bit before the New Year's. We were taking a look at the hatch parameters. We're going to look at those again. We're going to put them into a param class, which is it's a way of parameterizing Python classes. A really neat library that we're going to check out. That enables us to make visualizations with Holoviews and put some panels together with widgets and visualizations using the panel library. So we're going to do a bit of an introduction into that ecosystem. And then we're going to dive in. We're going to take a look at the new hatch.js parameters and start plugging them into these libraries and just see how that works, the basics, how to get the widgets going, how to get the visualizations going. And then we're going to do sort of a free form. We're just going to build from there and see how far we can get and answer any questions along the way. And if you guys can get your workflows going, open up a terminal if you want to follow along. If you're just going to watch, that's fine too. And any questions so far? Cool. Nice. Okay. So let's take a look at these libraries. So we have Python param. Now, it's all in the name, right? What are we doing here? We're trying to figure out the hatch params and visualize them. So this seems like a good place to start. So param is a library providing parameters. Python attributes extended to have features such as type and range checking, dynamically generated values, documentation strings, default values, each of which is inherited from parent classes if not specified. So we can see here we're able to create a Python class and it just inherits this param.parameterized class. And then we can give it these param attributes like numbers, booleans, etc. And we can have bounds on those parameters. We can have default values, and we can have documentation. So this is just good practice in general software engineering to have basically types and bounds. It means anytime your system starts to go outside of these ranges or types, it'll notify you. It can either crash with an error or it can put out a warning in your logs, things like that. So this is a really good practice in software engineering, but it's so useful for data visualization because once your data is annotated like this, you don't really ever have to think about how to use a visualization library again. It should just all come for free because nowadays there's an ecosystem of data visualization libraries that given annotated data, they just know what to do with it. And the main library that implements that is called Holoviews, and these are all part of an ecosystem. This is actually a really cool kind of story to be told. It's actually all made by this one guy, this one genius guy, who's like a neuroscience researcher. And then it's supported by a whole team through Anaconda and the whole sort of PyViz ecosystem, and it's all open source code. It's a really good example of a well-built, well-documented open source ecosystem. So with param, we can then extend that to this Holoviews data visualization library. And the slogan here, like I said, stop plotting your data, annotate your data, and let it visualize itself. So that's what we're going to do with these libraries and with the hatch parameters. Holoviews is a really powerful and extensive visualization library. You can do a ton with it, but it has a bit of a learning curve. So on top of that, there's a library called hvplot, which makes it really simple. It's essentially an interface into the Holoviews plotting library, and it gives a really simple API. And we're going to play around with this today. This is what we're going to use. We're actually going to go through this. This is cool because this is a Jupyter notebook. Actually, all of the documentation here is our Jupyter notebooks that are rendered to HTML. And so you'll see what I'm talking about when I say workflow on learning these libraries. We're actually going to clone this repo and work directly on this tutorial. So that's hvplot. And now the last library I want you to start to think about that fits into this ecosystem is called Panel. Again, it's made by the same team. And this is a high-level app and dashboarding solution for Python. And essentially what it lets you do, if you have these sort of Holoviews objects, then they're actually composable. This is one of the cool features of this library, is you can add two plots together using the plus operator, which will literally just put them side by side or on top of each other. And you can use the multiplication operator, or the star operator, to actually put two plots on top of each other. So if they have the same axes, then it'll just work no problem. Yeah, so the multiplication operator essentially like joins plots by axes and allows us to easily compose these dashboards and have these widgets and connectivity between our charts. So this is the sort of stack that we're going to use today to visualize our economies that we want to deploy, or in this case, the TEC hatch. So the workflow here, all of these have a GitHub repo associated with them. And we're first going to take a look. I'm going to use this hvplot as the example. So I'm just going to, again, Google hvplot. And we get the GitHub repo here. Okay, and this is the guy. I think we should all find him on Twitter if he's on Twitter. Philip. He's basically started all of these libraries and is the primary maintainer. I don't know if he's on Twitter. Either I followed him before or not. I kind of forget. Yes. Everyone should follow this guy. He's like the genius. He's an absolute genius. Okay. Senior software engineer at Anaconda, neuroinformatics PhD, creator of Panel, Holoviews, GeoViews, core developer of Bokeh and Data Shader. He's in Berlin, Germany. So, a little shout out there. Philip. He's quite active on GitHub. If you ever have a question, you can just go post issues on these organizations, and he'll usually respond within a day. Okay, so let's try this out. Now I want to jump back a little bit. We're going to open up I've consolidated the lab resources into a single repository, which is called the TEC Lab. And so right now it just has a running, I actually couldn't remember where Lab 2 and Lab 3 were. So that's a little, we can put that as a housekeeping note in the lab organization. So where are Lab 2 and Lab 3 files? Someone could go watch the recordings. They're probably in some repository that I just don't recall. So we got Lab 1, Lab 4, and Lab 5. Now what I've done here, if you're familiar with Git, you can use this git ignore, and it will ignore all these files. So it's just nice for development. Sometimes there's different artifacts that are created through the development process, but I've added this folder called Scratch. So that's going to get ignored by Git. And so what I do in my local development environment, so I just bring up a terminal here. Okay, so in the repository here, now locally I have this folder called Scratch, and I can do whatever I want in there, and it's not going to pollute the Git repository. It's not going to be tracked by Git. So you can run all sorts of your local projects and research and experiments, and you can mess around in there. You can put any files in there that you want and not have to worry about if they're going to get pushed to Git or not. So we're going to go into there, into that Scratch folder, and I'm going to clone this hvplot. Sweet. And while I'm at it, so we're going to play around with hvplot and also panel. So GitHub, here we go. Oh, yep, panel. If anyone's following along, if you get stuck or anything, let me know. We can slow down a bit. Come on, internet. Okay. So now we have these two libraries that we're going to use, and we'll notice if we activate our virtual environment and open up Jupyter Lab, then we can check them out, and they follow this standard, which is really useful. So we go into the repository, and they always have this examples folder. So this full stack of parameterized classes and visualization, all of the repositories have this in common, that if you go into them, they're going to have this examples directory. And this is actually all the documentation that we were seeing earlier in the browser. So for the hvplot one, we can open up the home page. And now we have an actual Jupyter notebook that corresponds to their documentation. So we could go through this. Let's see, high-level plotting API for the PyData ecosystem built on Holoviews. Very cool. This whole ecosystem is very nice. I've seen, for example, Block Science uses this NetworkX quite a bit to do network modeling. X-arrays really come in handy for modeling n-dimensional data sets. It's a sort of generalization of pandas. And then we get this nice ecosystem, and data shader is for like scalable visualizations. So no matter how large your data is, it allows you to sort of zoom in to one piece of it at a time, so you can visualize infinitely large data sets. And then here's some more on the ecosystem. And I guess I recommend everyone to go through this at your own leisure as you have time. We won't go through all of it now, of course, but let's just check it out a bit. So they're importing pandas, they're creating a sort of a date range, and then they're creating a random data set, 1,000 points by 4, so they have A, B, C, D here, and they load that up into a data frame. And how this works is when you import hvplot, it does something called monkey patching, which is a design pattern in software engineering, in which case it actually overwrites the pandas built-in plotting function, because I think we could do this. Pandas already have this plot function. So this is the default that you just get with stock pandas. And when you import hvplot.pandas, it actually monkey patches your data frame to now have these hvplot functions. And so we get something like this. Rather than just a static image, this is actually interactive. We can zoom in, and we can pan, and we could save this as a PNG, etc., etc. So we get all this functionality just with a simple import. So there's all sorts of cool stuff here. Violin charts, they're examining crime data. And then this is where they talk about this composition that I mentioned earlier. So using this star plot. So they superimpose two plots here on top of each other, and then they add a plot beside it, which is just the table itself. And then you can even use this streams library to have streaming data frames, and it's you get this streaming visualization with almost no effort at all using this same hvplot interface. And then they do some geospatial stuff, I believe. This I had to you guys might get stuck here on installing the dependencies, and don't worry about it too much. Cartopy was the one that took some time. But anyways, this is the hvplot library. Check that out. I don't want to get behind schedule here. So let's look at panel now. Same. So this is a different repository panel. It's got this examples. We're going to go into user guide, and we're going to check out this one called param. All of these are really cool, different ways, like components. We can actually, I didn't look at this before. Let's just see if we could run it really quick. What do we get? Oh yeah, these are just all the different components that we can. So this is where we're going to get our widgets from, and this is cool. But let's take a look at this one called param. This is what I want to do today. So this is kind of an upgrade of our last lab. We're going to use these parameterized classes. Last month we were just making individual widgets and then seeing what we could do with them. But today we're going to do something much cooler. So this is the way of combining this param class with the panel library that allows us to build dashboards. And so what we do is we parameterize a Python class, and we define all of its attributes using the param syntax. So you see here what we get access to. We can have just a general parameter that's like your any type, or we can have strings, integers, floating point numbers, ranges, dictionaries, Boolean values, colors, dates, data frames, objects, lists, files, multiple files, and actions. So you could get very creative with this and compose it into some complex functionality. So this is really, if you just read one documentation page out of all this, this is the one you're going to want to find to start utilizing these parameterized Python classes. And here's the example of all the widgets that you can put together. There's even a file selector here, so you can load up files dynamically. So this is good for like loading data sets and stuff like that. And they go through this. They show you how to they compose like geometric things, and they get this map explorer. So some inspiration for what we could do from like a data science approach when it comes to analyzing all of our tech data now and down the road. So that's kind of a whirlwind introduction. It's really just showing you how to explore these libraries. So start with the documentation, and then go to the GitHub repo and find the contributors on Twitter, and then clone the repos and run the examples. And so now we're going to put it to use. So we've got our lab here. Can probably close some of these for now. And let's see. Oh, nice. Blair. Yay. Okay, so let's jump out of this documentation. Okay, so I need to go back here, and I was in the Scratch, so I'm just going to go up a directory into the lab, and I'm going to run Jupyter Lab from here. Okay, so let's take a look at Lab 5. Yeah. And we have access to our documentation, so we can open up any of those examples that we wanted. Maybe I'll leave the panel example open. So let's take a look at Lab 5. So I did some impact hours modeling. We might bring that in with what we're doing, but let's start out here with the hatch parameters. So this is what we had last month. We had copied in parameters from newDAO.js, and maybe I'll give a shout out to Griff and Sem. Is there any particular changes that we should be mindful of moving from that newDAO.js to newhatch.js? Because I believe these were copied from newDAO.
The hatch, the impact hours for sure. That wasn't in there. What else wasn't in? Well, newDAO, the big newDAO.js is totally different. It has bonding curve. It has everything, right? So you cut out all the conviction voting stuff. You cut out all the bonding curve stuff, and you include the impact hours stuff and a few other little pieces.
Okay, so we probably want to just Should I just blast these and start from scratch with?
I think so.
Okay.
I think so.
So that's
The thing is that last time we kind of erased already the things that we didn't need, but it's okay. Let's do that again.
okay. So now we have new hatch. Yep. So let's just stop me on every section that's okay. I know we did this last time. It's too bad we're doing it again here, but okay. I'm just going to start fresh. Do we need this hatch oracle ratio?
Yeah, because this is the CSTK ratio.
Okay.
You had those already on top.
Okay. So
And they are different because there is a contribution. There is a new variable there. Maybe it was not needed, but the last one in that specific block, contributions proceeded per transaction. Yeah, that one we don't need it actually.
oh.
No, we don't need it.
Okay.
Sorry.
That's okay.
Yeah.
So we have the hatch oracle ratio. Let's start here, right, with the dandelion voting settings. Okay, this is perfect. This code's actually cleaner than the new DAO as well. So that's good. Okay. Oops. Okay, so let's actually just start with these. Hey, Mishko. Okay, okay, so what we're gonna do now, we're gonna create a class which is a dandelion voting, and it's gonna be a param dot parameterized, and we'll just go through these. So let's think about support required. Okay, so we're gonna use this. So it's gonna be a number, param dot number, and the default's gonna be 0.6. Now, what are the bounds of this? And we can make these constants as well. For any of these, some of them might make sense to be constants. I guess this could be from 0.1 to
0 to 1.
0 to 1, yeah.
Yeah, it probably 0.1 or even less. 0.01. I don't know if we can add as a strict 0 there.
Yeah, there is a way to do it. Let's come back to that in a bit. So I think this is good. We can set a step, I believe, to be like 0.1 or no, 0.01. Okay. So let's see if that works. So then we can use panel.pane dandy. Oops. We can instantiate it, so we can say dandelion equals dandelion voting, and okay, so now we have something. So this is a start. Okay, so let's keep rolling on these. It's nice to actually type them out because it forces us to read them and think about them. Min acceptance quorum equals param dot number. So the default 0.02 bounds equals. So let's think 0. Okay. Minimum acceptance should be 0 to 1 for now.
Yeah, I'm not sure if there is a relation between super required and minimum acceptance. Maybe you need minimum acceptance to be lower than support required. I am going to check out in the code. Meanwhile, you continue if you want.
Yeah.
One is okay, but let's see if there is any other restriction.
Okay, let's try that for now. Actually, so duration blocks has to be greater than 0, that's for sure. Vote buffer blocks. So default to 8, and this is hours. Okay. And then vote vote execution delay blocks equals, okay, same. Oh, these are actually integers. So let's make this an integer and make this an integer and param dot integer, and this defaults to 24 hours. And okay, tollgate fee. Set the fee paid to the org to create an administrative vote.
Effectively, the minimum acceptance quorum must be less or equal to support required.
Okay, so we'll think about that in a bit. We'll see if we can impose that constraint. Because I know last time we tried that where we put in the minimum bound to actually be the value of this support required. And I'm pretty sure that's possible to do, but I hadn't looked into it. Haven't looked into it yet. Might be a homework assignment. So let's say tollgate fee param dot integer 3. Okay, let's just see what this looks like.
It doesn't have to be an integer. It could be decimal. Because it's like it could be 0.5 if we want.
Okay. So looks like it gives us these sort of selector widgets on the integers. I know you can customize the integers, so we could look how to do that. But this is our base dandelion voting template. So we've got a support required 0.6, minimum acceptance quorum 2%, vote duration blocks is 3, vote buffer blocks is 8, vote execution delay blocks is 24, and the tollgate fee is 3. Good. So we can do a dandelion voting. Let's keep going, I guess. Let's get the hatch settings. Okay.
Did we erase it? This is going to be very equal to what we did last time, and I think that it's better to recover what we did.
Well, we were doing it in a different way. We actually did it a different way. We were building independent. So what do I have here? So we have some here. We actually have a template we can work with. Yep. Good point. So let's call this the hatch. And so how many collateral tokens? So hatch minimum goal. Oh yeah, we have that set here. And here it's set to 5. And okay, so the bounds, let's say a minimum of. So this is for the test hatch, I guess. That's why it's 5.
Yeah.
Okay. So
Yeah. It's just 5 die.
okay. So and then a target goal. Oh, max goal. Should it be max goal or target goal?
That's interesting. Right now, what we have is a max goal in which, if we reach that, the hatch ends and it ends. But we are also talking about having a kind of target goal or something like that, showing the front end, which is also going to be. It might be something, but not for the smart contract.
Okay, let's call it max goal for now. That's what we have. So max goal is set to 1,000. And okay, let's see. Let's say 1,000. Okay, so next is the hatch exchange rate. So the hatch, so that is, what should this be? Oak times fundraising token. So, fundraising 1 token. What is this value actually?
Actually, I'm really glad you're asking Sam this, because when I look at that, like, I don't see the right result in the app when it happens, you know? Seems like you should get 10 million tokens, but instead you only get 10,000 or something for one wrapped X die. What's up with that, Sam?
Let me check it out. The hatch exchange rate.
Yeah, I actually made a forum post about this that will show you where it's, or Jake, I think Jake made it. I don't remember who actually authored it, but I reviewed it and it's weird.
Yeah, that's good. I think that we already kind of solved it because in a previous version, the thing is that you have to multiply it by fundraising 1 token and divide it by it's because of the decimals that each token have. I'm not sure. I think that we understood that and documented it well, but probably now that changes has been lost in the transition to the new hatch script. I have not the response right now, but
so
I can.
Basically, the hatch rate. I put the forum post in the TE Labs, and basically the hatch rate when it's set to 3, 6. Oh man, I can't tell how much that is. Like 7 zeros and a 1 point, basically 1 Satoshi. When it's set to 1 Satoshi, then 1 wrapped X die gives you 10,000 test TEC, which is just really weird. I don't know.
Yeah, we have to check it out.
But at least we could write that in the comments. You can, if you want, YGG, because I had to test this manually, and I assume that this new hatch.js was the thing that was used to deploy, right? Like it didn't get changed.
We have to check it out. For the moment, we can use it as it is, and then come back and fix it if we have to.
Okay, so we're getting into another example here. So any sort of dependencies where we have dependent variables, they can be encoded in this way, or really any function. This is how we're going to do our visualizations and stuff later too as we tweak these parameters. So we use this param decorator, param.depends, because I see I'm getting towards the vesting cliff period here, and it's actually a function of the hatch period. So I'm going to do that. Let's see, def. So I would call this update vesting cliff period and self and
Wait a sec. The vesting cliff and the vesting complete period are not going to be parameters that we are going to touch in the hatch, because they are going to be applied in the new DAO. They are here because we need to vest until the hatch is ended, so the tokens cannot be moved. But they are not actual parameters of the hatch. So if
yeah. Okay, so they're needed for the smart contract, but they really are not part of the hatch. Okay, good to know. Vesting cliff period, vesting this one as well. And then what percentage of hatch contributions, hatch percent supply offered equals fundraising 100%. What percentage of hatch contributions should go to the funding pool and therefore be non-refundable? So we have this hatch percent funding for beneficiary.
yeah, I think that the first one, which is 100%, it's not either a parameter, because it will mint TC tokens for the funding pool, and we don't want that. So it's 100%, and it's set up as it is. Maybe we have to remove that parameter, because
yes, please.
Yeah.
Are you talking about this one? Supply offered?
Yes.
Okay, yeah.
That one is
and
so.
The other one is the hatch tribute.
This one is the hatch tribute.
Yeah.
Yeah, let's call that hatch tribute.
Which splits the dice into the funding pool and the reserve.
I sort of think that it's more like because the hatch tribute is going to probably be more than it will be determined. The final hatch tribute will be, maybe it's like initial hatch tribute or forced donation, or because there will be another hatch tribute which will actually split between the bonding curve and the funding.
No, that's the one. Maybe you are talking about the cultural tribute.
No. But when the DAO upgrades to a commons, it will be able to change this. It will be able to add more to the funding pool if it wanted to.
If we do the split at this point, when we do the hatch, when we finish the hatch, the dice are already split, and the natural thing is to move the funds as they are. The Dandelion voting would be able to move the funds inside of the vaults, so applying a different hatch tribute, but it's not the expected outcome. The expected outcome is that the migration goes as from that reserve to that reserve, and from that funding pool to that funding pool. That's the expected
I would
outcome.
say it wouldn't make. I don't think it makes sense to determine the hatch tribute without understanding the rest of the bonding curve and the conviction voting parameters.
Like
it would be. It's like incomplete and unnecessarily restrictive. Like when. And I think what will happen is like this hatch tribute, whatever it is, it'll probably stay small or even be zero potentially. And it will say like all of that will go to the funding pool. But then of the larger vault, one transaction would go to the funding pool and one transaction would go to reserve.
I don't know if that's we discussed it in legal 2 or 3 weeks ago, if the first donation is important or not. That affects that discussion. I think that we should have that discussion in another moment, but that would affect how we do the hatch. And if we just need 1 volt or 2, which could be an interesting discussion, but I don't want to take time from YCG, and we can just continue.
It's just
we
weird
can just
'cause
continue.
when
Yeah.
I was in that discussion, I was pretty sure that the idea was, oh, we might be setting this to 0. It was part of the options, right? So, like the initial hatch tribute might be 0, and then,
Mhm.
but anyway, yeah, you're
Yeah,
right.
yeah.
We can keep moving.
Good discussion, guys. This is a big. I think that's awesome. That's great that it's coming out of the labs. Because sometimes it takes this sort of visual stimulation to just think, oh yeah, that I thought this was this, or I thought this was this. So I'm actually stoked that this is happening. But anyways, so we have the hatch here. We have the dandelion voting, and that's really, I realize that's the end of the params here. Other than
No, yeah.
Okay. I think these. Oops. Ah, what did I do? Impact hour rate. Okay. Okay, so let's make another. So, max impact hour rate equals ram dot number 0.01. So max impact hour rate. Oh, max theory. Oh, is this R from the equation?
Yes, it is. It could be. No, it could be much more.
Oh,
It could be like 200 if you want.
cool.
Because it's the maximum that somebody could get in die for their job in 1 hour.
This is awesome. Let's see if we can I think we can visualize that equation in 12 minutes. Hopefully. I think we can do it. Okay, 0.012 times 1 token divided by 10 times okay, so this should do it. So okay, so now let's see if we can so we have the data here, we can come back to that, but let's just see if we can move towards rendering the equation. I have it here as a resource. This one, I think. Oh, no. Oh, yeah, impact hours. This one.
Yeah, this one.
Oops. Awesome. Okay. So let's take this. Okay, so let's think here. Let's just plot this first. So we should have, let's say if we go I equals impact hours, then we have I dot max impact hour rate, and we have I dot expected impact hour rate. So we can use those in this equation. Okay. X greater than 0. Okay, I think we can do this. So similar as we did last week, so we can import numpy as np numpy.linspace. Then we can create our x-axes. So from 0 to, let's see, what is x?
millions. Yeah, X are total raised, total funds raised.
Okay. So let's go from, oh, it should be, we could use our hatch. So we could say H equals our hatch. And then we get like H dot min goal and H dot max goal. Okay, so we can go from H dot min goal to H dot max goal. Okay, so this is our x-axis. Now we want to apply our equation, which is essentially this one. So x over x plus mh. So let's just define r, m, and h in here. So r is actually equal to r impact hours. Might be something like that. M and h. So what's this expected raise? Oh, that's h, I think, right? Or m.
No, M and H are the total impact hours.
Okay. And h is
Yeah.
so then we can say y equals r times
X.
x over x times
Yes.
plus
No, it's
plus
M.
times h
H.
for x in oh, actually we need that. Say x equals x. Okay, so then we should be able to make a data frame. So data frame equals pandas dot data frame. Maybe xy, something like this. Okay. Zip.
Yeah, you need another one.
Actually, just go transpose. Okay. So now we get our hvplot. Probably just like that. That's not quite right. We need columns here. Columns equals x, y for now. We could probably give it better names. Let's see. Df dot columns equals. Try this. X equals x.
Wow. Yeah.
Awesome. Phew. So we have 6 minutes. Good. I think we're ahead on time. So I think we should be able to make this interactive. So let's see. Just got to put this all together now. So this is just an import. Put this up here. And so we have these. Okay, so let's take this. Oops. And this is self.
And the other one, why dot expected? Probably it's also self, right?
Yeah. Okay. All right, let's give that a try. Okay, so we need to go I equals impact hours. Oh, I had this, oh, it's this. Yay, okay. So now we can play with these. So that's good. We got to a good point here. Maybe I'll make this a...
Yeah, it could be also a slider.
Yeah. Expected raise per impact hours. What do you think?
It could be 0 to 100. I don't know.
Cool.
Okay, it's too much. It's too much. Well, actually, maybe it's because the max well, it depends. It depends. But with the current one, it's too much because it floods so fast, you know.
Okay, awesome. So this is a good start. I think we're... Oh, my clock's glitching out. That's weird. Do you guys see this? Typical Linux.
Yeah.
So I have no idea what time it is, but I feel like this is a good session. This is actually a really good place to be. I'm going to push all of these updates, everything I've got here, I'm going to push it to GitHub, and it'll be all accessible through the central repository, which you can find here, and under Lab 5. And yeah, I do recommend people try out the little Git hack where the Scratch directory is Git ignored, so you can do any sorts of experiments in there. You can clone any sort of repositories, and you'll see that in my Jupyter lab I have it all available here. So I have all the labs, and then I have my Scratch, and I have my references. I can go into the hvplot examples and check out all of the NetworkX, for example. And yeah, so I want to continue this next week. We'll pick it up where we left off. I think I'll make some progress on this actually throughout the week, and I hope that everyone else does as well. These notebooks are good to run. You shouldn't have any problem running them. I've got a requirements file in the repository. So let me just show that. So there's instructions here on how to create a virtual environment and install all the requirements. And then you should be able to just run Jupyter Lab on your system, and message me or post in the Tech Labs channel if you have any difficulties with that. And by the end of next week, we should have a nice sort of hatch template that we can, by the end of next week's lab, we should be all cloning it and making our own copies of the files. And then we can bring that to the whole tech community and get everyone involved at that point.
It has been super cool to check out the Holoviews.
Oh, it's awesome! It's a whole rabbit hole. This stuff is so great. It's a good community. It's actually a good model of open source developers, but they have no idea about tokenomics and cryptocurrency. So like bridging those worlds is huge, I think.
Mm-hmm.
Yeah. Anyone know the time?
It is 59.
Cool. Anything else? Anyone have questions or anything?
No, that maybe you said that we follow you on Twitter, but you didn't, or I didn't manage to see the Twitter. So.
Oh, okay. I'll just.
Actually, I already follow you on
It's
Twitter.
YGG_Anderson on Twitter.
Yeah, on Twitch also.
Yep, also on Twitch, and that is pinned in the lab channel.
Okay.
Okay, well, thanks all for coming out. I really appreciate it. It's nice to see so many faces in here. I hope you guys learned some good stuff, and I'll see everyone next week. And stay active in the Tech Labs. I do check that channel, so I'll try to answer any questions that are in there.
Thanks for the session.
Thanks, everyone.
Yeah, thanks, Sean.
Yep.
Bye.
Take care.
Awesome.
Thank you so much.
Thank you. Bye.